What's up? Can you folks see me? Can someone type something in the chat? Can you folks see me and hear me? Yes. Is this thing working? Yep, all good. Seems like you folks can see me. Awesome. Awesome, awesome, awesome. Can I see some highs in the chat so I would know that how many people are there, at least a rough estimate? Okay, awesome. So then, let's get started. So today I will be taking a session on computer networks. So let me present my screen. Thanks, Pasha, for doing all the reporting and stuff. So can I pop the chat out? I don't think so. So let me just take it to a different tab. Boom. Right. Um, yep, this should look good. Present and present. I think, yeah, I think you folks should be able to see your screen and I should be able to switch to the chat. Yep, that will be cool. Chalo, let's get started. So let me also open my chat here so I can just, yep, let's go. So today we are going to talk about computer networks. So why I chose this particular topic of computer networks was they always somehow found a way to just piss me off to like beyond no belief. Because whenever I used to see some IP addresses or people talk about proxy, reverse proxy, they just went into my head. I didn't understand what they actually meant, what was actually happening. How can someone trace you through the IP address, but sometimes they cannot and sometimes they can. So like it was pretty confusing, like able to see all this jargon and still not being able to understand that. So today I will try to give you an overview or kind of like a surface level understanding of how a networking course would start. We will not talk about stuff like OSI model and stuff because that I don't like it too much. It's important for sure, but it can kind of get confusing sometimes. And like we generally need a broader time frame to like understand all that stuff. So yeah, I will just try to give you a general overview and being able to actually relate those things which we theoretically read with some actual practical examples of where we will actually try to read stuff like so if you might have seen things like this where someone goes ping and types a random thing and then they suddenly start seeing this and they're like okay my internet is working like what the hell is ICMP, what is TTL and what is time. So we'll try to like basically understand what is actually happening. So yeah, let's get started. Was that fine? Was it working properly? Pasha, can you do your reporting duty? Yep, awesome, awesome. So first of all, like today's agenda is going to be what is an IP protocol, rather what is a protocol, then asking a lot of whys, like why does an IP protocol exist? Why does a TCP protocol exist? Why does a UDP protocol exist? Why do all these protocols exist? Like why are there so many protocols? Why there's not one protocol? Then we will try to read Wi-Fi. Basically, if you have ever connected to a Wi-Fi, you will see the address, subnet mask, your gateway. What do all these things mean? Then we will try to read ping, your this thingy. We'll try to basically read what was happening here, and then we will try to demystify some stuff. So yeah. who am I? So, hello, hello, hello. My name is Sushant Mishra. Okay, did something happen? Just ignore that. So, hello, my name is Sushant Mishra. This image might not look like me because right now I am bald, but I used to have hair like a week or so ago, but now I'm bald. So, my name is Sushant. I was a developer intern at Catalog 5 before I left that place, and I'm currently a core member of Hyderabad. Generally, most of the time, I'm building full stack applications or writing some Rust here and there. That's a brief introduction about me. Now, let's get to what the hell is a protocol. So, like, let's take it as a starting point. What is a protocol? Then we will go into remaining stuff. So instead of this is the computerish definition of what a protocol is, we'll try to go in a general traditional protocol thing. Like what does a protocol even mean? The term protocol. So it's basically a formal agreement. Now here I have written nation states because like I was taking a traditional analogy. So if you have two countries and like if you have what do you say? If you have some treaty or something, that's basically an agreement between two countries of how the things are going to happen. So protocol is nothing but how two entities can relate to each other. So if you have ever written something like a function, so function, then a set of arguments, and then what happens with those arguments. So that function is also a protocol because you're defining what will happen to this variable. So on the internet, if two machines have to communicate with each other, they need some set of protocols like how am I supposed to send data? How am I supposed to receive data? What am I supposed to do if I don't receive the data? What am I supposed to do if I get overloaded with the data? So all those things are mentioned in the protocol. Now, so this is how I think about protocols. So like the funny thing I think about protocols. So let's say I take you and I tell you to go from A to B. Now you are a human. You will take care of everything. So let's say I tell you to go from place A to place B. You will figure out the transportation. You'll figure out the timing. You'll figure everything out basically and do it yourself. But on computers, when I tell you to go from A to B, since computers are so dumb, like literally, that you need to explain to them everything. Like if you want to go from A to B, this is how you do it. This is what you do if you can't go to that place, and like a lot of instructions to basically say that okay, go from place A to place B. So that's basically how things will be happening. So, yeah. So what the hell is a IP protocol? So we learned what is a protocol. Protocol is nothing but a way to relate two entities or like send some data from A to B. Like it's just a protocol. Like protocol basically means like if you meet someone, you shake their hand. That's protocol kind of thing. Now, what is an IP protocol? And but like you must have heard the term IP addresses or something like IP, like public IP, private IP. So IP is nothing but internet protocol. Am I right? Yeah. Wait. IPP, Internet Protocol. What? Am I right? One second. IP full form. Yeah. Internet Protocol. So my bad. IP is nothing but Internet Protocol. This other protocol won't come there. So IP is nothing but Internet Protocol. Internet Protocol is nothing but a way for you to tell how can a data go from place A to place B. Technically, it just means that it's a way for you to send packets from place A to B. Now, what are basically packets? So if you are able to see my live stream right now, what is actually happening is not that my whole image is like being taken in one sip and sent to your computer. My image is being broken down into pieces, and those pieces are like then transmitted. So they are basically getting converted into pieces. So big data is broken down into chunks and then send it to you. So if you have ever downloaded a file, for example, like downloaded a cracked game or something, so that game is generally very huge, like 1 to 2 GBs. So I can't just directly send it to you. I need to break it down into chunks and then chunk by chunk, I will send it to you. So that's like basically IP protocol helps you in that. Like basically its job is to just send data and how to send data, we'll see further. Now, for IP protocol to work, basically, you need IP addresses. So if you want to say like go from A to B, you need a way to say like, okay, this is A and this is B. You need an actually unique way of doing this. So the data can go from place A to place B, but how do you define places A and B? So are we all caught up till now? Let's see if we are all caught up. Was there any questions or like did you folks not understand something? Let me know. Or am I going too fast or am I going too slow? What is the size of a packet? Okay, that's kind of a good question. What is the size of a packet? So the size of a packet is actually decided by once you actually have like a connection between A to B. The size of a packet will be decided by what's the MSS, basically maximum segment size of B. So basically what is happening is this B guy will have, let's say, a box with him. And on every time you try to contact, like in the TCP protocol, like in any protocol, he will say, like, I can take this much data and then you will send it that much data. For example, if I am, let's say B, I say that you can send me 64 KB packet sizes. So you will send me 64 KB packet sizes. If I tell you I can only handle 16 bytes, then you will send me 16 byte packet sizes. So it depends on the receiver, how much packet sizes they can handle. Like for example, Cloudflare, since they generally have very beefy servers, they have a very big packet sizes, generally 64 bytes. But yeah, you can change that depending on what you want the packet size to be. Awesome. So yeah, let's go to IP addresses. So IP protocols basically need addresses to actually work. So yeah, let's talk about addresses. So everyone has a public IP address and a private IP address. So let me show you my private IP address. So if I do something like IPA, so if you look over here, this is my private IP addresses. Now you might have guessed, since I am able to show you this, this is not like you cannot use this to trace me out. This is just my private IP address. But if I do something like what is my IP address.com and press enter, I'm not going to press enter, of course. Otherwise, you will be able to see my public IP address and then you can figure out a way to find me. But yeah, so private IP is something that is internal to your context. I will explain to you how it is and how it is internal to our context. But public IP is something which is in the public and can be used to trace you kind of. So yeah, so public IP is something which is used by your ISP. ISP basically means your internet service provider. So your ISP is something like the guy whom you brought your internet connection from. So he uses your public IP address. So any communication that goes through him will use your public IP address. Whereas a private IP address is something which your router gives you. So for example, every morning you wake up, you switch on your router, and let's say you connect it on your phone. Every time you switch on your router and try to connect your phone, it's very likely that it will give you a different IP address because it's a private IP address. It's given to you dynamically. It does not matter what's the IP address of my phone, because like I can change it every time because it's a private IP address. Whereas a public IP address changes very less frequently, and only your ISP can decide how it changes. Now I know the picture is still not clear. It's very confusing what is happening. Like I know you might not be able to understand it, but as soon like as we go further, things will become very clear. So yeah, let's look into what is private IP address and what is a public IP address. So if you see these numbers over here, these are basically ranges. So you go from this range to this range, this range to this range, and this range to this range. Now, if you see any address in that range, it's a private IP address. For example, my private IP address was this 192.168.0.6. So it comes into this bracket. So that's my private IP address. Now, the funny thing about these private IP addresses is that if, let's say, any router finds these IP addresses out of my network, like in a place where they're not supposed to belong, it will just drop it. For example, if I try to send a request to um, an IP address like 192.168.0.4, and let's say it does not exist in my network, and I try to send it outwards, the other router will just drop the packet and ignore it completely because they have no meaning. So this is how it works. So this is, let's say, your ISP, your internet service provider. You go to him and you ask for a connection. Like, hey, I need an internet connection. So what he will basically give you is a public IP address. Public IP address is unique. Don't share it with anyone. And even if you share it with someone, it's very unlikely that they will be able to trace you, but still, it's not a good idea to share a public IP address. So your ISP gives you a public IP address. Now, the thing with public IP addresses is that they are IPv4, meaning that it generally just means that there can only be possibly 4 billion IP addresses and there cannot be more than that. Now, if you think how many people use internet right now, it's way over the limit of 4 billion. So if you go and hand out the public IP address to everyone, we will like run out of IP address very quickly. So what we generally do is for a single household, generally, a single household will have a router, and that router will have an IP address, which will be a public IP address. Now, every device which is connected to that router, for example, my laptop, which you're seeing in me right now, my phone, they all will get private IP addresses. These private IP addresses will be assigned to us by the router. So router uses something known as DHCP, which basically assigns addresses to all the devices in its network. So I think that might give you a clearer picture of what is happening. So your ISP gives you a public IP, and your router basically gives you private IPs. Now these private IPs can frequently change, but your public IP mostly remains same or stable until your ISP decides to change it. Yeah. Was it clear? Address availability. So Kota is asking a question like, can a device have both a private and a public IP address availability? So, that's actually a good question. Uh-huh. Let me think. Can a device have both a private IP and a public IP? Yes, it can. To be honest, yes, it can. It only depends on the context. So, how should I explain this? Let me think. Yep, it can. I will show you. So let's say if you look over here, can I see my gateway? No, I can't. But generally, what is happening is, so if you see these addresses, right? 192.168.0.4, and like you see these addresses, like only the last digit is changing. So what generally happens is like in a network, your router has a public IP, which it uses to connect to your ISP. But your, let's say your phone, if it wants to talk to your router, it will use something known as a gateway IP address. So I think I have a slide for that. So yeah, if you see over here, this is my router's private IP address. So my router was given a basically a public IP address by the ISP, and I was also assigned a private IP by itself. So my router was like, okay, this is my private IP. If anyone in its own network, for example, if my phone wants to talk to my router, it will use this IP address. But if something outside of my network wants to talk to my phone, it will need to use my public IP address. So that's basically it. The router has both a public as well as a private IP address. Did that clear it out? Was it clear, Kota Ratnakar? I hope that was. Is everyone on point till now, or did we miss something? If you have any questions, you can drop them. Yep. Awesome. 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 Okay, I think then we can move forward. So yeah, this was the basic the jargon about private IP addresses and public IP addresses. So now I think we can move forward to something known as a subnet mask. Let me see the time. Okay, it's 3 o'clock. We can aram se do it. Not a problem. Oops, my bad. Yep. Then let's talk about subnet mask. Now let's think about it. So let's say I have a router, right? How many devices can connect to my router? Like, what is the limit of connecting to my router? Can one router handle 1 billion connections? 1 million connections? How many can it actually handle? That's actually a pretty fun question to ask yourself. Like, how many connections can my router handle? Is there even a limit? So, first of all, yes, there is a limit. And how many can it handle depends on you. You can decide how many networks it can handle. So, if you have seen my IP address, basically, so if you see my IP address, basically, at the end of my IP address, there is this /24 thing, which like seems out of nowhere. Like, what is the meaning of /24? So that /24 is basically my subnet mask. So if you see these numbers, basically, this number 192.168, these all numbers are like a byte long. What does that mean is that let me take my 192 and let me go to something like, okay, I think I have a diagram over here. I don't need to go anywhere. So if you take my number like 192, this is basically a number which is a byte long. A byte basically means 8 bits and they look something like this. So 192 in binary form can be represented like this. So 11000. If you have like taken like first year of college, you will be able to understand this. A good way you can, should I show you how to decipher this? Does everyone know like how to convert a number to its binary representation? Like if you don't know, like just let me know. I will like show you a small example of how we can convert this number to this number. Does everyone know how to convert a number to its binary representation? Okay, you know it. Nice, nice. Is there anyone who does not know how to do this conversion? Okay, it seems like everyone knows. Awesome, awesome. Okay, seems like everyone knows how to do this conversion. So basically, this number gets converted into a binary, which looks something like this. And you can do this with all the numbers. So like zeros will all have all its bits turned off. One will have only one bit turned on, and like every number can be represented like this. So below this, I have written something known as a subnet mask. This thing over here is a subnet mask. So what that means is, oh my bad. So if you see this 24, right? So this 24 actually means 3 bytes because like 8, 3 is 24. So like segments of 8, 3 times. So segments of 8, 3 times. So this is that 24 number. So when I write something like this thing /24, I basically means take up these 3 bytes. So 255 can be written like this. This 255 can be written like this. It basically means turn all the bits on. 255 is like the last number in like 2 to the power 8 representation basically. So why this number? Why do we even need this number? Like what is the meaning of this number? Why do we even use it? So why we use it for is pretty awesome. So this number from this point to this point is like our network. And this zero thingy tells us how many hosts we can have. So let me show you. So what is happening is, let me take an example. That will be awesome. Let me take the image of this. Let me go escape. Let me go to Excalibur. I think like this was the point which actually made me like networks because I understood this point kind of. I would like to explain it. So let's say in your house you have a phone. Let me move this bigger and let me move this smaller. Boom. Let's say in your house you have a phone and you have basically another device, let's say a laptop. Okay. And let's say your phone has an IP address of 192.168.1.3 and your laptop has an IP address of 1.2. So this is basically your phone's IP address. These are both private IP addresses. So this is your phone's IP address and this is your basically laptop's IP address. Now let's say you also have a router which you basically use at your house. ROUTER. Now you have a router which has an address of something like 0, basically. Or I think generally 1, but it's fine, not a problem. And let's say the subnet mask of this whole network was that 255 thing we were talking about. So this thing was a subnet mask, right? So now let's say your phone wants to send some data from your phone to your laptop. So what I will do is I'll basically be like, so what happens basically is your phone will tell your router, like, hey router, I want to send something to this IP address. Now, how does your router know that the IP address your phone is talking about is not an address outside of your network, but rather a network inside of your network? So your phone wants to talk to your laptop, but it's up to your router to decide if the request should be sent outside of your network or should it remain inside of your network. Now, if you don't know what a network is, basically this thing. Your router, all the devices connected to your router basically form your network. So your phone wants to send some data. It wants to send some data to your laptop. You just need to figure out if it's inside or outside your network. Now to do that, what you do is you basically take the IP address of the thing you want to send something to, and you do an AND operation with your subnet mask. So you basically take the receiver's IP address and you do an AND operation. So when you do AND of both of these things, you will get this. It it will basically give you this. Now this looks very similar to this because the first I'm back. I'm back. Can you folks see me again? For some reason, my laptop just decided to die off. Am I back live or not? Let me check 1 second. Awesome. We are back live. Yeah, yeah, yeah. My laptop just died. It just decided like, okay, you're doing too good. Just end it over here. So, yeah. So where were we? We were over here, right? Yep. So what was I on about? This my phone wants to send something to my laptop, and now my router needs to figure out if that thing I want to send data to is in my network or not. So I basically did an AND operation and I got this. And since the first 3 bytes are same as my phone's first 3 bytes, I can say that, okay, this is in my network, so I don't need to send the data outside. Now, if by some off chance this was something like this, and the first 3 bytes were not matching, this would mean that this is outside of my network. This is not inside of my network. So that's basically it. So this subnet mask generally helps us decide if something is in our network or is outside of my network. So now if my phone wants to talk to my laptop, just need to send the request to the router. The router does this AND operation, sees that are the first 3 bytes matching or not. And since they are matching, it's like, okay, it's in my network. Let me just find out whose it is and just send it to that. If it was not in my network and it was like going outside, the first 3 bytes would generally not, like always not match because it's out of my network. And my router will then decide of what to do with that and try to send the network outside. So let me go to that slide. Let me present. So that's how a router basically works. It it makes the decision of to send something outside or remain inside of a network. Now, when I say it's going outside, basically somehow finding a way to go to your ISP and from ISP to somewhere else. That's what basically happening. This is your IP address. This is subnet mask. The subnet mask just basically is helping you if you want to send some data outside or remain inside. Now, this is like a good image kind of thing of like of visualizing stuff. So this was the subnet mask we were dealing with till now. But if you are a big corporation and you want to basically have multiple routers, for example, a router for your IT department, a router for your finance department, and you want to like segregate all those things, you basically try to change the subnet mask. So over here, this is the subnet mask. If you like take one more zero and make it one, your host will fall basically. So this 000s is like you can connect to 256 hosts. If you take one more one up, you can connect to like 126 hosts and like slowly it will reduce. So you will basically have more networks, but less hosts. So this is how it will look like. So this was ours. So we only had like one network where all the machines were coming. But if you try to change your subnet mask, you can change the number of networks you have, but the number of hosts will drop down. So this is what your basically router is doing. If you're someone like a very big corporation who wants to like let's say like your ISP who has a very big network, what you will do is instead of taking ones from here, like instead of adding ones here, what you will basically do is you will start taking stuff from here. So you'll make this 0 0. So now you have more hosts. You will take this whole thing. Now you have more hosts. So this is basically what you're going to do. So this won't, of course, this won't remain 255. This will become 255, 255, 0 0. So the more hosts you want, the more changes you will make to this basically. So that's what your subnet mask is helping you do. Let's move on to reading your Wi-Fi. So I think till now everyone was up to the speed. Did everyone get it? What was subnet mask? What was IP address? What was this IP? You mentioned /24. Slash 24 basically means so 24 is like 8 3 is 24, right? So 8 was like this thing. Let me show you. So you see this thing, right? So here, if you try to count from here to here, like if I count, this is basically 8, this is again 8, and this is again 8. So it's basically like 8 3 is 24. So basically, that's my subnet mask. So if I see this 24, right? This was getting converted to this because I was taking the first three bytes. This is one byte, this is one byte, and this is one byte. So I was taking up like total of 24 bytes. So that was my subnet mask. Let's say if this was something like 8 to the 16, then my subnet mask would look a lot different. So then my subnet mask will look like this. But let's take this here. So my subnet mask would basically look like this. It's basically changing your subnet mask. Only the first two bytes are important now, and these remaining two bytes tell you how many hosts you can have basically. What is slash 24? I just was my explanation clear this time, or is it still unclear? Why do we have a slash 24? Slash 24 is nothing but just like how many bytes are there in your subnet mask basically. How many on bytes do you have? So this right, you can just basically count from here to here. This is like 24. So you add a slash 24, basically means you have like 24 bits on. That's it. Was it clear? Mhm. Great. Okay, awesome. Quote, I understood it. Nice. Ashwin Dada joined the stream. Awesome. Yep, I think we can move forward. So we can go ahead and now basically 1 second. So now we can actually go ahead and start reading our Wi-Fi. So if you have like ever connected to like some public Wi-Fi and try to see on your phone like these things like IPv4 address, a subnet mask, and a router, I think now you can generally understand what is happening. So this was basically from an airport. So on the airport, I got assigned a private IP of basically this and a subnet mask of this. Now, what's the thing I love about networking is that by just reading this, I can decipher a lot of stuff. Like by just reading this, I can tell that this network can have around 255 hosts. So like that's kind of the limit. And I think it's 2 to the power 8. So like there's a lot of hosts. I think I've written over here. Yeah. We can have like 254 hosts, around that many hosts. So I can tell that okay, this airport can have like 254 hosts, at least the router I connected to. And the actual router where I am sending my data to has this IP address, which is its private IP address. So that was like a fun thing I found. That's why I'm getting like interested in networks a lot nowadays. So yeah, we can read Wi-Fi, and now we will basically try to read ping. So now with ping, we'll come back to our IP protocol thing. So let's get to know what a ping is, how a ping works. Now I don't have slides for it, so I'm just going to use my terminal now. Let's see what a ping is. So let's say we do a ping. Now something is happening. It's saying something like 64 bytes from some random number, an ICMP sequence, a TTL number, and a time. What is happening? Can someone like does anyone have any idea what is happening? In the audience, does someone know what is happening? If you folks don't know, that's awesome. If you folks know, that's also awesome. Does anyone know what is happening? Any general idea of what might be happening at least? Kota just said that he has no idea. Anyone else having any idea what might be happening? It seems like you folks don't have an idea of what is happening, which is awesome because now I can take my time explaining what is actually happening. So, first of all, like, what do we generally use ping for? What is ping? So, generally, where I have used ping is to know that am I connected to the internet or not. So, for example, if you have like a graphical user interface, what you generally do is if you want to check if your internet is working or not, you just go to google.com, right? But in a server, you don't have the liberty of using a GUI. So, what you generally do is you go to a terminal and type something like ping 8.8.8.8.8. Okay. So now this 8.8.8 is an IP address. It's a public IP address. More specifically, it's Google's DNS IP address. So basically, Google has this server or like a lot of servers, which basically has this IP address of 8.8.8.8. It's used for DNS, but we won't talk about DNS. We will just try to decipher what all these things mean. So when I say, okay, ping this address, what's happening is I'm trying to send a packet to that address. So I take a packet. So if you see over here, I'm sending a packet with this much size. I just send it to the server. And now I want to see if I will get my packet back or not. So it's basically a way to check. Can I go there and can I come back? Now, if I don't have internet, I won't be able to go there and come back, right? But since I have an internet, I can get all these outputs. This basically means that I'm getting something back. So now what is happening? So let me draw a beautiful, very beautiful diagram. What is happening is basically, let's say you are the user, or let's call you a client, basically. Client. And let's take a server over here. And this server has a public IP of 8.8.8.8, basically. Yeah. So this is Google server. So what is happening is you want to somehow send something from here to here, basically a packet. So you want to send it from your client to your server. So what is actually happening is not like you take your packet and just throw it to the server. Like that will never work. So what is happening most of the time is you have a router here. This router is basically sending it to some other router, and then it goes to like a lot of routers after this. But at the end, most likely it will end up at your ISP, the guy who provides your internet. So it will go from here to your ISP. Now it's your ISP's job to figure out where it should send the packet. So your ISP, as you asked it to, it will send you to this server. So if you have a client, you want to connect to this, and you need to go through a lot of intermediaries to actually reach that address. So now this thing happens. Now your server is like, okay, I got your packet. Since your internet is working, I got it. Now I send you back a response. So it will now it's not compulsory that the route your packet came from, your it's like it's not necessary for it to come back in the same route. So it's not like if I go to college using a route, I'm going to come back using the same route. I can just take a U-turn and come back. Like I can decide how I want to come back, which is convenient for me. So let's, for simplicity, let's say that it comes back using the same route. So I then come back to this router, let's say, and I come back to this router and I am back to the client. So I go and I come back. So now this going and coming back is of course going to take some time. And this is this time. So it took my this wala packet 17.4 milliseconds to go to the Google's DNS server and come back. So we now understand what this is. This is a round trip time. The amount of time it took us to go from my computer to the server and back. This was the round trip time. But what is the ICMP sequence and what is a TTL? So now The funny thing about packets is that, let's say what happens for some reason, my packet is never able to reach my ISP. For some reason, what happens is it comes to this router and it goes to some other router. Now, from this router, it goes to some other router. Now, the intention of the packet is to go to this, but it's never able to reach this place. For some reason, it just got lost because there is no directional path, right? If I go from machine A to B and I tell machine B, okay, I want to go to machine D, and then I tell machine D, I want to go to machine E, I can just keep on chaining things like that. I can basically form a loop. Like a lot of things can happen, and my packet might never reach the server. So a case can be there where I sent a packet, but it was never like the server was never able to get it. So what happens to those packets? Do those packets always remain? Like, do they always stay alive? What do you folks guess? Like, do all those packets like stay alive or do they die off? What do you folks think? Can I create a poll? Let's not do that. My computer might shut down. Can be. Like, what do you folks guess? Can those packets like remain alive or do you think they will die off? Kota says that he has no idea. Anyone else who wants to say like, do they have an idea or not? Die off. That's a very blunt way to put it, but yeah, it will die off. The packet will die off, but you just need to see how it will die off now. So what happens is that whenever you leave a packet, that packet has something known as TTL, which basically means how much time it has to live. So every packet, like for example, when we sent our first packet over here, it had a TTL of 59, which basically means that it can do 59 jumps before this packet dies off. Basically means that, let's say I have a packet over here. Let me take a packet. A packet is nothing but it contains an information basically, like what you want to send and stuff. Let's say this packet has a TTL of around 60. Let me make this awesome. So I can't increase the size. Yeah. Okay. Select. Yeah. Let's say this packet has a size of 60. Now it goes from my PC to my first router. This router will take this IP packet and basically decrement the TTL number and basically make it like 59. Then it will take one more jump and basically make this packet 58. And once again, if my packet jumps, it will make it 57. So on every jump, my TTL will keep on getting reduced. So over here, the TTL is 57. So if this keeps on happening, and let's say it never reaches the server, and somewhere around here, when it just keeps on jumping, its TTL becomes zero. TTL means time to live. So now, since your time to live is zero, you can't live anymore. So that router will basically take this packet and kill it. I know that sounds kind of um, I don't know, I don't know the word, but that is what is happening basically. So whenever you send the IP packet, it basically has a time to live, and the time to live keeps on getting reduced whenever you go from one machine to the other. Basically, on every jump, your TTL keeps on getting reduced. And if you are not able to reach the server in a finite TTL limit, and your TTL for some reason becomes zero, the router will just drop your packet, meaning it will just kill it. It won't send it any further. So yeah, so that is what this TTL packet is for. This TTL packet basically is telling us, okay, here the number 59 was sufficient. Basically means in 60 jumps, it was able to reach a Google DNS server and it was fine. If it for some reason wasn't able to, then it would have been a different story. Then basically what we would have done is like basically increase this TTL number until we actually reach the Google DNS. So we will just keep on increasing it until it's finally able to reach there or not. So yeah, that's what a TTL does. And now we have one more enemy, which is basically a ICMP sequence number. So what is ICMP? So how we basically use ICMP is that let's say my packet was killed over here. For some reason, my packet died over here. Okay, and how will my client know that did my packet die or not? Like client should know, right? That my packet died. So what this router, being a good citizen of the internet, will do is it will send back an ICMP message. Now ICMP full form. Yep, I don't remember full forms because that's useless. ICMP basically means Internet Control Message Protocol. So what this is doing is, okay, your packet is supposed to die now. I can't do anything about it. So what I'll basically do is send back an ICMP response. ICMP response. This response basically says like, oh, hey client. So we got your packet, but it was not able to reach the destination. So we dropped it. So this ICMP message will go back to the client and get me like, oh, okay, you're not able to receive my packet. I will send my next packet with a higher TTL number. So it will basically increase this TTL number to something like, let's say 120. So that is what basically ICMP is used for. Here, what ICMP sequence is signifying that, um, like ICMP 1, 2, 3, 4, 5 basically means that it's kind of like numbering. Okay, it's like it reached the destination. Like my first packet reached the destination. Then my second packet reached the destination. Then my third packet reached the destination. So these are all like in sequence. So like there is no packet which got dropped. Basically, that's what it means. Generally, ICMP is used for like sending out a message if something bad happens. Like for example, your router is not able to handle a lot of requests. It will generally just send back ICMP response like, "Hey, I'm not able to handle a lot of requests. Can you just stop sending data?" So it's like a messaging protocol which like routers use, which is pretty helpful. And let's move on to the next part. What do we have next? These three things they confused the living hell out of me. Like, what does an IP address? Like now, I think you folks will have a general idea of what an IP address means. But what are port numbers and what is a MAC address? This was like kind of confusing. Like when you already have an IP address, which can uniquely identify your machine, why do you need ports and why do you need a MAC address? So now, first of all, why do you need ports? Now, ports kind of has a simpler explanation. So if you let's say on your like, what can happen is that um, let's say this is Chrome. Let's do my browser, right? So this is Firefox, and I can open a different browser, something like now. What I can do is I can go to Google.com on this browser, and I can also go to Google.com on this browser. But the funny thing about this is that I asked for Google.com, obviously. So I got Google.com, but how did the packet know where to go? How did it know that it should come up on this screen and not this screen? Why did it happen that when I typed google.com over here, this is where google.com appeared, and when I typed it over here, this is where it appeared? So this is all happening using something known as ports. So every machine can have like a finite number of ports. I think there is a limit. I think that's 2 to the power 8 again. You can just Google search it. How many ports can a machine have? So it can have these many ports, and I think that around 2 to the power 8. No, it's more than that. It's to the power 16. Yeah, to the power 16. So I think I can show you why it's to the power 16. So if you go to, what is it called? IP segment diagram. IP G dot. I think there's a very awesome diagram somewhere over here, which basically explains why ports is like to the power 16. Over here, do I see ports? PORT, PS, port, source port, no, destination port. I can't find the diagram, but like it's a really awesome diagram which basically shows you that okay, why can we have two power six? Um, IP address. Oh, sorry, IP protocol. Packet diagram. Yeah, I think this is the one. Yeah, this one. This is the one. So if you see, like we have something known as, do we have ports? Source address and like destination address. That's fine. We should also have like ports somewhere. I can't find it, but if you see through the proper packet diagram, you will see something known as source port and destination port, which will basically have a diagram like this basically. So over here is going from 0 to 31, but basically ports will go from 0 to 16. And that's what I wanted to show you. But yeah, this is the one. This is the one. This is the one. So what is happening is the senders and receiver machine have their own IP addresses. That's completely fine. But you also have something known as ports. And why you have ports is because you can have multiple apps open. And then your computer needs to go through the headache of finding out like which application am I supposed to send back the data to. So let's say Firefox requested something. I need to make sure that it gets back to Firefox. So yeah, this is basically ports are helping you in. So ports go something like this. So you will have a IP address, and let's say then at the end you will have like double dots, and you will have like 3000. So this is my IP address, and this is my port. So to this PC on the app, this running on port 3000. So over here, of course, you are not seeing those numbers, but everything we type on the URL bar at the end of the day is getting converted into numbers, and which basically somehow gets converted. Like at the end of the day, gets converted to this. So that's what ports are used for. We need a way to figure out where to send back a response to. So if two machines are talking, unless you're talking to your friends on WhatsApp, right? So WhatsApp basically has an IP address, which is basically a phone's IP address, and it has a port number, which is reserved for itself. So any response coming back to WhatsApp will go to that port number. Like a funny thing you might have noticed is that if you're on a flight somewhere, you're going somewhere, and you try to use WhatsApp or something like that, you can only receive text messages. You can't receive photos because that's kind of not allowed. And how they are able to do it is that how WhatsApp is able to do it is that WhatsApp has separated where they get their text from and where they get their basically photos from. So like they're receiving their text on a different port number and they're receiving their images on a different port number. So they're able to block one port and allow one port. So port is nothing but at the end of the day, telling your phone key, this was the device, like this was the app which wanted the information, send it back to it. So IP is clear, is ports clear. Uh, does my Wi-Fi router have a role in packet transfer for some other person's internet? Hmm. Hmm. Yeah, it can. It it can, I guess. It's kind of a hard question to answer, but it can. It's not an issue, right? Like I can send a request to your PC, right? So let's say I try to send a request to your router, and then your router basically has to acknowledge it, and it needs to figure out if this request is basically a response to something it said or not. Basically, I think the answer is yes. It has to figure out because I can basically DDoS you if I want to, right? DDoS means basically means denial of service. So I can flood your router with packets. So I think yeah, it does have a role. I might be wrong. I might be wrong. I need to check on this, but I think it does. I think it does. So did you all get what ports are? Mhm. Chandra, I will try to get back to you. I think I'll post it somewhere. I'll post like a thread on Twitter or something like, does your Wi-Fi play an active role in like the whole internet transference? I think it does, but yeah, we need to check it once. Did everyone get what ports are? Can I get some yeses or nos in the chat? That would be awesome. Or did you guys just sleep off because I was so, what do you say? My voice sounds like a lullaby, I guess. Awesome, awesome, awesome. So that was ports. Now, what is a MAC address? A MAC address is nothing but a unique identifier again. So why do you need a MAC address? Like we already had an IP address, right? Which was uniquely identifying my PC. So every morning I wake up, I switch on my router, I connect to my phone, I get an IP address. So why do I also need a MAC address now? Now, why you need a MAC address is because your IP address keeps on changing. That's your private IP address. Every time your phone connects to your router, it can have a different IP address. It's not necessary for your phone to have like that same IP address every time. So to have something solid, which basically does not change on your phone, which can basically be mapped to your phone, we use a MAC address. This is basically your hardware provider gives you this. So whenever you buy a new phone or a new laptop, it has an inbuilt MAC address, which you cannot change. Like kind of in the modern days, you somehow can fake it, but it's on your hardware. So like you cannot change it basically. So every manufacturer has to create basically their own card, which has a MAC address, which cannot change. So that what MAC addresses are used for. IP addresses again can be changed. MAC address can never be changed. Like they always remain the same. Now some demystification. I think we're near to the end of the session. So some demystification. So this is what I used to think first of all. Like when I got into networks, I used to think that if I have an IP address and I show it to the public, they can somehow trace me. So if you go on the internet, you will try it. There are services basically, services promoting that you give us your IP address and we will tell you where are you from. So if I give you my public IP address, can you trace where I am? Technically, yes, but it's near to impossible. Like there is no way that you can trace me basically. So whenever you go to some service like IP address to location tracker, what they're basically doing is they're taking that IP address and trying to figure out who the ISP is. So they take their IP address and find out who the ISP is, but they can't go any further than that. If you actually want to know where I am, only my ISP can tell you that. So there is no app. You cannot do anything to find out where I am without my ISP intervening. But let's say if you're the government who has control over the ISP or like goes into the ISP and asks like where is this user from, the ISP will tell you where it's from. But in general scenarios where you like get a scam call or something, the problem is not so big that the government will intervene and like go through all the addresses and try to figure out where you are. Your ISP can technically do that, but you'll never in a real life scenario never do it. Or if you're a very big underworld criminal, then they might, but generally they don't. Then what about MAC addresses? Can someone track me using my MAC address? Again, the answer is yes, but that's near to impossible. The thing with MAC addresses is that they never leave your network, so they always stay inside of your network. A MAC address is just for inter-network communication. So your MAC address, your machine also has an IP address. Your IP address is basically used for communication, but your router to know where you are basically uses a MAC address. So your MAC address network never leaves your network. So you're completely fine. Like no one can track you. Like over here, if I do IPA. This is my MAC address. If you want to, go ahead, track me. You can't. It's near to impossible. Until you have my public IP, then it might become a little easier. But again, my SP needs to intervene. And yeah, that's it. Thanks a lot for joining. This is not my this is not my thing. Let me just change my LHW dot app. Yeah, that's my thing now. Thanks a lot for joining. Like all of you who stayed till the end and listened to me speak. And yeah, I hope you learned something. You enjoyed something. Chandra has a question. How does private browsers like Tor work? How is the IP changed without tracking your activity and identity? How is the IP changed without tracking your activity and identity? The thing with Tor is that, from what I have heard, is that like if you do www, if you go try to go to some website on Tor, what it basically does, it has like a layer kind of structure where it basically keeps on, I think it keeps on forwarding a request. That's why it's pretty slow. Like you will never be able to actually use the Tor browser properly because it's so goddamn slow. But I think what Tor is basically doing is like creating layers. So like things become harder to track basically. So like technically again you can track a Tor browser, but it will become very hard because it's using some layer kind of structure. That's why. But you will in a practical scenario, like it's very hard to use a Tor browser. How does an incognito tab work? Incognito tab basically does nothing, to be honest. Its basic job is to like not store history, not store cache, not store tracking cookies and stuff. Incognito, like again, I think this is the thing with incognito, right? I think even if I show you on my browser, right? If I go to, yeah, I think over here it will show a disclaimer, right? Um, yeah, over here it says this is an incognito tab, but this doesn't make you anonymous. It's basically to remove tracking stuff, but incognito won't make you like anonymous and stuff. It just stops you from storing history, stops you from storing cookies. Yeah. It has data from incognito. Incognito is like, I think people have like developed a false sense of security around incognito. Incognito does not hide your identity. It's just a way to like not store cookies and not store trackers. So like some days back, I built this app. What that app used to do is like, it will basically fetch your IP address from somewhere and then send it to me. So basically, if you run that application, it will go somewhere, get your IP and send it back to me. But if you open that tab in incognito, incognito will prevent that. It won't let me go to that particular service provider, fetch your IP and get send it back. But yeah, it still won't help you because the funny thing is, if two machines have to talk, let's say A has to talk to B, B needs a way to send back the response to A, right? So I need to know A's address. So no matter what you do, I will always know who A is until and unless you're using a VPN or something. So what a VPN basically does is, let's say I want to send something from A to B, that A will first go to a VPN. It will basically my all requests will go to that VPN set provider. My VPN will take that request and send it to this. Now this guy's job is to send it back to the VPN provider and send it back to me. So VPN is basically taking that role of like protector or like a request forwarder, basically. It's like saying, um, it's like me telling a friend to do a Google search in place of me, basically. This is basically VPN does. So instead of like the response coming back to me, it goes to the provider and then the provider can send me the response. Yeah, that's it. Any other questions or like anything else you want to ask? Feel free to ask. So even using an IP does not contain IP address which can be tracked. No, you will always have. So even using incognito tab does contain IP address. Yeah, of course. It always contains an IP address. Uh, like there can never be a case where you don't have an IP address. You need to have an IP address. Even in incognito tab will have an IP address. It will try to put some protection, of course. That's the whole point of incognito, but you will never be safe. How is DNS mapping does? Does DNS have separate servers? Yes, DNS has separate servers. Like I showed you this, right? Thing 8.8.8. This 8.8.8 is nothing but Google's DNS service provider, basically. So whenever you want to send a request to someone, like to an IP address, that IP address, basically if I want to go to something like google.com, this google.com gets converted into an address. So that DNS mapping is done by a server. So I go to the server, does a DNS mapping, and then sends out my request. Generally, that's taken care of by your ISP and stuff. But yeah, DNS map is like a very long register basically. It's basically like, okay, this is the domain name and this is the IP address. Let's match them up, send them out. It's done by a server. Like Google has a lot of servers. 8.8.8 is like generally their server. So yeah, that's how it's done. Any other questions? If you do have any other questions, feel free to drop them. Or you can also reach out to me on my Twitter and stuff. I'll just put the link over here, I guess. So on Twitter, I'll go by Sushant Street. That's my Twitter. If you have any questions, feel free to ask over there. You can even ask here. Yeah, I will send you the slides. I'll put it on GitHub. If you go to Hyderabad's GitHub, you will find them. So yeah, I think that's all. Okay then, it's time to see off. Bye bye, folks. Thanks a lot for joining again. And we will send out the feedback form in the WhatsApp group. So yeah, if you have been following along LHW for the past 1 week, you can submit back your responses over there. You can give feedback over there. And yeah, that's all. Thanks a lot for joining. Bye bye.